Good morning, students. Welcome to the second lecture of state of matter. And in first class, I have already discussed about the important characteristic properties of gases, and one of the important gas law, that is Boyle's law, I have discussed. Okay, so now and few numericals based on Boyle's law also being explained. Now, what these gas laws are? Basically, all these gas laws correlates among the four measurable properties of gases. So, what are these measurable properties? Okay, so it's very important to know the measurable properties of gases. Measurable properties of gases. You know, there are basically four measurable properties. These are pressure P, okay, volume V, next one that is temperature T, pressure, volume, temperature, and finally that is amount of gas, that is, or you can say number of moles, that is N. So we have to correlate among these four properties in gas laws. So first one, you just remember that this amount of gas is always taken to be constant. Okay, this is always fixed, or you can say constant, fixed quantity or constant. Amount of gas is always taken to be constant. Then out of these three variables, okay, we have to keep one constant, like that of in the previous class I have told you about Boyle's law. So what are the constant quantities in Boyle's law? Amount of gas for a given mass of a gas. You can remember the mass of gas is constant and at constant temperature. Then we have got the relationship between pressure and volume, that V is inversely proportional to P. That was our Boyle's law. Or you can write, or V that is equal to K by P, or you can say PV that is equal to K. Product of pressure and volume always were constant, or you can write P1 V1 that is equal to P2 V2 likewise. Okay, so these are the different forms of Boyle's law, and I have told you about the graphical representation. Let us repeat it again. The graphical representation of Boyle's law, that was very important. You see, and you see, if I represent V is inversely proportional to P, okay, pressure and volume, so these are inversely related. If I put a graph over here like this one I am taking pressure and this one volume, and what are the constant? Number of moles of gases and temperature. These are the constant quantities. So how V varies with P? It is inversely proportional. So the graph can be drawn like this. At every point the temperature remains same. Suppose I am considering at point A, at point B, what about temperature? Temperature remains constant. Okay, so at high pressure volume is minimum, at a high volume pressure is minimum, and this variation obtained by keeping temperature constant, so that this rectangular hyperbola is called isotherm. Isotherm means at similar temperature, at constant temperature. Okay, so this is a rectangular hyperbola. Am I right? And next, if you plot a graph between, that is V and 1 by P, or you can say indirectly P and this one is 1 by V. Okay, so these two are directly related. So see that relationship. Other way I can write P is inversely proportional to V. Is that clear? That implies P that is equal to 1 by V into K, some constant. So you can write like this is equation 1. Okay, Next, if you compare this line, this P as y and this 1 by V as x and this K with M, then you see you can compare this equation with y that is equal to mx plus c. You see there is no c at all, so you can compare y is equal to mx, and you know the graph of this line, that is a straight line passing through origin. So the graph will be like this, straight line passing through origin. This is the graph between P and 1 by V, and you can say or V versus 1 by P, similar case. Okay. Next, if I am doing a graph like this, you see this one, P versus 1 by V, and I am getting graph like this one, and one at this one. Is that clear? Every line passing through this origin. Let's say this one is at, I can write over here, temperature constant. So here let's say this one is T1, this one is T2, this one is T3, let's say. Okay, so what is the order of T1, T2 and T3? You see why the slopes are like this. Okay, so what is the relationship among three temperatures? So if you can compare an equation that is PV that is equal to nRT. Okay, this is ideal gas equation, you just remember right now, PV that is equal to nRT. Okay, now the equation that I have got over here, you see P is equal to 1 by V into K. That clear? So I can write over here P that is equal to nRT upon V, and here just see P that is equal to 1 by V into K. So if I compare these two equations, say suppose equation 2 and equation 3, if I compare these two equations, then 1 by V into K that is equal to nRT by V. You see, so V get cancelled, K that is equal to nRT, and this Nr is constant number of moles of gas and universal gas constant. So K is directly proportional to T. मतलब T जितना ज़्यादा होगा और K का वैल्यू भी उतना ही ज़्यादा होगा. So here what is K? K is slope. K is slope. So slope का वैल्यू डिपेंड करता है किसके ऊपर? टेम्परेचर के ऊपर. So more the temperature, more will be slope. Then here you can write down the order, that is T1 is greater than T2 is greater than T3. Am I right? So more the temperature, more will be slope. Okay. Next, I have got another graph that I have told you, that is this one is PV. Am I right? PV, and we have compared with it, let's say pressure P. Okay, so graph obviously PV that is equal to K. So this one clearly indicates whatever the value of pressure, there will be constant value we are getting, T1, T2, T3, T1. Let's say this is T1. Okay, let's say this one is T1, this one is T2, this one is T3. Okay, again here the order will be T1 is greater than T2 is greater than T3. Okay, so since P, pressure and volume are inversely related, more the value of pressure, volume will be certain amount of less quantity of volume will be there, so that the product will be a fixed value. Okay, so slope, as I have told you, T1 is greater than T2 is greater than T3, because more the value of T, more will be K. Okay, you can simply write like this. In Boyle's law, PV is equal to K we have got, and from ideal gas equation PV is equal to nRT. Right now this left sides are equal, you just compare this one, K is direct proportional to T. Okay, so slope will be maximum, the value of PV will be maximum as the temperature go on increasing. So this was all about your Boyle's law. Okay, so I have told you several numericals, let us explain what is Charles law. Okay, very important law. So let us explain the further important law, that is Charles law. Charles law. Okay, Charles law, again we have to keep number of moles, and here in Charles law pressure, these two are constant. Then tell me we have to find out the relationship between the rest two measurable properties, that is volume and temperature, V and T. Is that clear? So what is the statement? At constant pressure, the volume of a given mass of a gas increases or decreases by 1/273 parts of its original volume at 0 degree centigrade for each 1 degree rise or fall in temperature. That clear? So the volume of a given mass of a gas, again amount of gas is constant, increases or decreases by 1/273 parts of its original volume. Original volume means the volume at 0 degree centigrade is taken to be its original volume. Am I right? So if the temperature becomes 1 degree centigrade from 0 degree, then the increase in volume will be V naught by 273. Just see, let explanation I can write over here. Explanation. Let V naught be the volume of gas at 0 degree centigrade. At 0 degree centigrade. Okay, so that is the original volume. That is original volume of gas. That is the original volume of gas. That is V naught. So at 1 degree centigrade, that means you can conclude over here that increase in temperature, that is 1 degree centigrade. At 1 degree centigrade, the volume of the gas will be equal to, tell me, V 1 degree centigrade, that will be V naught plus increases for 1 degree rise in temperature, the volume also increases 1/273 parts of its original volume. So that is at 1 degree centigrade. So 1/273 parts of its original volume, that is V naught into V naught. So I can write over here V naught plus V naught by 273. This is the increase in volume due to 1 degree rise in temperature. So that can be written as V naught into 1 plus 1/273. Is that clear? Next, suppose I am considering at further 1 degree rise in temperature, that means at 2 degree centigrade, I can write the volume of the gas, okay, will be equal to V 2 degree centigrade. Then tell me, that will be V naught plus V naught by 273, that was the original volume, that was at 1 degree centigrade. At 1 degree centigrade, the volume was V naught plus V naught by 273. This one is at 1 degree centigrade. Then further for 1 degree centigrade, that is at 2 degree centigrade, the increase will be again this much, V naught upon 273. So V naught upon 273 plus V naught upon 273, that will be 2 V naught by 273. So that will be equal to, I can write V naught into 1 plus 2 upon 273. Okay, so likewise, if I proceed like this, so at T degree centigrade, small t, the volume of the gas becomes equal to V T degree centigrade, that is equal to V naught plus V naught into T by 273. So that will be equal to V naught 1 plus T upon 273. Is that clear? Now you see, you just remember this equation. This one I can represent like equation 1. Similarly, for decrease in temperature, okay, so at -1 degree centigrade, what I can write? At -1 degree centigrade, that is for decrease in temperature, the volume of the gas becomes equal to V -1 degree centigrade, that is the initial volume that was V naught. Again back to here, okay, the initial volume that was V naught minus, that will be decrease in this case, so minus V naught upon 273. Is that clear? So that will be equal to V naught into 1 minus 1 by 273. Is that clear? So similarly, at -2 degree centigrade, you can tell me the case will be very easy. -2 degree centigrade, that will be equal to V naught minus 2 V naught upon 273. Okay, that will be equal to V naught into 1 minus 2 by 273, like this. Similarly, if I proceed up to at -273 degree centigrade, okay, so tell me the case will be, okay, here, so the case will be V -273 degree centigrade, that is V naught minus, okay, minus 273 V naught by 273. This will be the value. So that again becomes, you see, 273 V naught 273, that will be 0. So at -273 centigrade, the volume of the gas becomes 0. Okay, because beyond this -273 degree centigrade, if you take -274, -275 likewise, okay, so there will be no gases. Gas can be there can be, it exists in the form of other state of matter. Okay, so this temperature at -273 degree centigrade, where the volume of the gas becomes 0, that is called absolute zero. Okay, so -273 centigrade, I can write over here -273 degree centigrade, at which the volume of the gas becomes equal to 0 is called absolute zero. So absolute zero means there is no gas, the volume of the gas is 0. So after that, if you consider the highest negative values, there will be no gas. Okay, gas cannot be exist, you can say. So -273 degree centigrade is also known as 0 Kelvin, that is called 0 Kelvin. So this is called absolute zero, where the volume of the gas is taken to be 0. Clear? So now you just focus this statement as I have mentioned equation I. So based on this equation, we can state the Charles law in some other way. Okay, you see. So next, if I draw a graph like this one, I am considering volume in this axis. Okay, so this is volume, and in x axis I am considering temperature. So one temperature. Clear? Suppose the graph I need to do over here between volume and temperature, and this one, let's say 100 degree centigrade, this one 200 degree centigrade, and this one 300 degree centigrade, 400 degree centigrade. Okay, so here that is 0 centigrade. Now, so in this axis, tell me this one will be -100 degree centigrade, -200 degree centigrade, -300 degree centigrade, -400 degree centigrade. Okay, so if I do a graph between volume and temperature, as so the graph I am getting over here like this. Okay, so you see between V and T we are doing it, and by keeping number of moles and what, pressure constant. Okay, so once pressure is a constant in this case, so if temperature constant in case of Boyle's law, we are called the curve isotherm, but here this is called isobar. We will discuss it. And if I extrapolate this line, then what we will get? So if I extrapolate this graph like this, so it will touches this point. This point is minus 273 degree centigrade. Minus 273 degree centigrade, where the volume of gas becomes 0, or it is called 0 Kelvin. This is called absolute 0, where the volume of gas becomes 0. That is called absolute 0. Okay, and minus 273 degree centigrade, absolute 0 correspond to minus 273 degree centigrade, where the volume of the gas is reduced to 0, or you can say 0 Kelvin. These are known as absolute 0. This is the graphical representation of your Charles law. Okay, now let us explain. So if you remember the derivation that just I have done now, what we have got, that Vt is equal to V naught plus V naught into T upon 273. Okay, so I can write this one V naught into 1 plus T upon 273. Again I can write V naught into 273 plus T upon 273. Okay, so beta, this 273 plus T, that is the conversion of a temperature into Kelvin. Suppose something is given as x degree centigrade. If I need to convert it into Kelvin, then I have to add 273 plus x, this much Kelvin. So here at T degree centigrade I can write over here, that will be more precise. At T degree centigrade, that is V naught plus T degree centigrade. T degree centigrade, T degree centigrade. So right now this one is converted into Kelvin. So I can write that is equal to V naught. Okay, so V naught into this one 273 plus T, I can write that one as T. Okay, upon 273. Right now you tell me, since original volume that is constant at 0 degree, at absolute 0, so V naught is constant. At 0 degree centigrade, V naught is constant. So V naught and 273, these two factors are constant. So I can write Vt, volume at any temperature, T degree centigrade, Vt, that is equal to some constant, let's say K into T. Okay, so V T degree centigrade is equal to K into Tt. So very simply I can write Charles law can be written as V is directly proportional to T. That means volume of a gas is directly proportional to absolute temperature. By keeping the mass of a gas N and pressure P, that is equal to constant. Hence Boyle Charles law can be stated as, I can write over here, hence Charles law can also be stated as, at constant pressure the volume of a given mass of a gas is directly proportional to absolute temperature. Absolute temperature is directly proportional to its absolute temperature. So beta Charles law can be easily written as V is a direct proportional to T. Okay, or you can say V by T is equal to K constant, or you can write like this, or you can write V1 by T1 that is equal to V2 by T2. This one also one expression of Charles law. Okay, so if we next we will proceed through its graphical representation. You can otherwise you can thought like this, from ideal gas equation you just remember PV is equal to nRT, very simple. Okay, so you are keeping this pressure constant and this n constant, so R is also constant, so you can tell me V becomes nR by P into T, so this factor is a constant, so V is direct proportional to T. Okay, so Charles law, I need to proceed further, that is, if I can mention over here graphical representation. Let us proceed through graphical representation. Graphical representation, very important. Graphical representation, first one, that is V and T, very simple. This one is let's say this one is volume and this one is temperature. So V and T are directly related. You see beta, V that is equal to V is direct proportional to T, that implies V is equal to KT. V is equal to KT. Let's say this one is V and this one is T. V that is equal to KT. So if I compare, this one is Y, this one is M, this temperature is X. Graph between X and Y. X and Y. So Y is equal to mx, that means straight line passing through origin. Okay, so here slope that is equal to K. Am I right? Let's say here I need to ask you a question, that is, if I represent a graph like this, that is volume. Okay, volume, this one I am considering, let's say B and this one is T. Okay, so I am getting straight lines like this. This one is, let's say at pressure P1, at P2, at P3 I am getting curve like this. Okay, so my question is, what is the order of P1, P2 and P3, whether P1 is less than P2 is less than P3, or P1 is greater than P2 is greater than P3, or you can say P1 is equal to P2 is equal to P3. Suppose my question is about this. Okay, so what is the technique over here, to tell me. So here if you compare that these three lines, just do the technique is you just do a parallel line over here like this. Okay, so beta here what is the value V1, at this point let's say it is V2, at this point let's say this is V3. Okay, so now consider PV is equal to nRT, PV that is equal to nRT. Okay, so here you see any line parallel to y axis, x that is equal to constant, so temperature is constant at everywhere. Here you are getting a fixed temperature, there is no change in temperature, so temperature that is constant, n constant, r constant. So what is the relationship between P and V, that will be P is inversely proportional to V, मतलब वॉल्यूम जितना ज़्यादा होगा प्रेशर उतना ही कम होगा. सो सबसे ज़्यादा वॉल्यूम किसका है, दिस वन, V1 इज मैक्सिमम. सो V1 इज मैक्सिमम मीन्स P1 इज less than P2 is less than P3. So here you can compare V1 is greater than V2 is greater than V3. You see, V1 V2 V3, V1 is greater than V2 is greater than V3. So V and P are inversely related. So obviously P1 is less than P2 is less than P3. That will be the order. Okay, so again you can ask me that why the slopes are like this. Again you compare. So V is equal to KT. So you can compare PV is equal to nRT. Okay. So you are keeping this pressure constant. So that implies V that is equal to nRT by P. So these are constant quantities. nRP you are keeping, pressure also constant. So you tell me. So here V is equal to nRT by P and here V is equal to KT. So I write KT that is equal to nRT by P. Okay. So K that is equal to N TT get cancelled, NR upon P. Okay. So this K is our slope. You see V is equal to KT, M. This K is slope. So slope and pressure are inversely related. So more the pressure, slope will be lesser. So you can see here this pressure is maximum, P1 is less than P2 is less than P3. So which one is maximum pressure? P3 is maximum pressure, so that its slope is present below. Okay, you can compare like this. Very good. So what we have got from Charles law, V is direct proportional to absolute temperature. Okay, so I can write over here V is equal to KT. So if I consider log V is equal to log K plus log T. If I consider logarithm, that implies I can write over here log T plus log K here, that is log V. So in this equation, if I consider this log V as Y and here definitely nothing is there, so slope will be 1 M. Okay, and this log T that will be X and plus this constant C that will be log K. So it is in the form Y that is equal to mx plus C. So you know what is the graph of this line? If I do a graph between Y and X, so that is log V and this one is log T. Okay, Y is equal to mx plus C. So its curve is like this. So this one is C, that will be log K. And tell me this slope that will be theta, that will be tan 45. Theta is equal to 45 degree, that is slope. So this is the curve graph between log V and log T. And here definitely the pressure is constant. So you can say here this curve, this plot is isobar. That means by keeping pressure constant. Okay, so this is all about your Boyle's law. Am I right? Okay. So now you see in this numerical, at what centigrade temperature, that means temperature is asking, will a given volume of gas at 0 degree centigrade, okay, become double of its volume if pressure remaining constant. So pressure is constant for a given volume of gas, that means mass of gas N also constant, right? So first one, that is at given condition. What are the conditions given over here? Volume at 0 degree centigrade, let's say V. Okay, so V1 I can let's say V. Become double of its volume. So next case, this one is first case. Better that will be, I can write this one is first case at given condition, that means first case. And a two-end case, very easy, you see. The volume becomes doubled, so I can write to V2 that is equal to 2 into V. Become double of its volume, pressure constant, and this at what centigrade temperature will a given volume of gas at 0 degree centigrade become double of its volume That means V2 becomes 2V and T1 is given you T1 0 degree centigrade. So 0 degree centigrade, or you can say 273 Kelvin, and it is ask you at what centigrade temperature. That means here T2 is equal to how much? It's easy. You can apply the formula V1 by T1, that is equal to V2 by T2. That implies V1 is given you V upon T1, that is 273 Kelvin, that is equal to V2, that is 2V upon T2. You have to calculate T2. So here this V getting cancelled out. So T2, that is equal to 2 into 273. Am I right? So that will be equal to this much Kelvin. Then you convert it into degree centigrade. So for degree centigrade, 2 into 273 minus 273, that will be converted into centigrade. So that will be 273 degree centigrade is your answer. Okay, very good. So next question, you see a sample of helium has volume of 540 ml. So you just write down case 1, first case, that is volume is given V1 540 ml at 27 degree centigrade. So convert this temperature into Kelvin. 273 plus 27, that is 300 Kelvin. Is that clear? So calculate the temperature at which the volume will become. So second case, so V2 is given you 270 ml. If pressure is constant, so pressure constant means you can know the relationship between volume and temperature. The pressure constant, that is T2 is equal to how much? Calculate the temperature. So it's easy. You just apply the formula V1 by T1, that is equal to V2 by T2. Apply this formula and calculate T2. Answer will be there. Okay. So next we will discuss the third important law, that is called pressure temperature law. Pressure temperature law, or this is called Gay-Lussac law, as per the name of the scientist, Gay-Lussac law. Very easy. Again here N and V constant, mass of gas and volume constant. So what will be the relationship between pressure and temperature? Pressure of the gas is direct proportional to absolute temperature, or you can write P by T, that is equal to K, or you can say P1 by T1, that is equal to P2 by T2. Am I right? So P is equal to, you can write P is equal to KT. Okay, so if I draw the graphs, that will be like this, P and T. So that will be y is equal to mx passing through the origin, there will be straight line, and here you see volume V is constant. So once V is constant, so that this plot is said to be isochore. Okay, so P and T, this is about P and T. So P is equal to KT. You see log P, that is equal to, can be written as log T plus log K. Again, basing on this equation, this will be y, that is equal to m is equal to 1 mx plus c. So m is equal to 1 slope. So if I do a graph between log p, this is y, and log t, this is x. So y is equal to mx plus c, like this, and here this much is equal to c, that is log k. And what will be theta? Again, since slope is 1, theta is equal to 45 degrees, tan theta. Okay. Next, back to here. So this one is pressure, and here this one is temperature. Okay, so I am getting plots like here. So let's say this one is at V1, V2 and V3. Volume is constant. So slopes are like this, because you know here P is equal to KT. Okay, again you compare P, V is equal to nRT, P is equal to nRT by V. So volume is constant, R is constant, N is constant. So I can write P is equal to, and here this one P is equal to nRT by V. Okay, you just compare this KT, that is equal to nRT upon V. So TT get cancelled. So K, that is equal to nR upon V. So its value depends upon slope K, depends upon volume V. So more the value of K, lesser will be the value of V. Okay, so here you see the minimum volume V1, V2, V3. You have to find out the order of these volumes. Okay, so first let us find out the volume order. So any line parallel over here. So this one is P1, this one is P2 and this one is P3. So PV is equal to nRT. Apply this. PV is equal to nRT. Okay, so any line parallel to y axis, x is equal constant, temperature is constant. So this one is constant. So if all these are constant, so P is inversely related to beta V. So find out the maximum value of P, P1. So P1 means V1 is less. So here the order will be V1 is less than V2 is less than V3, because pressure and volume are inversely related. Okay, so higher the value of pressure, lesser will be the volume of V1. So V1, V2, V3. So again back to here, K, that is equal to nRT by V. Which one has highest volume? That is V3. So V3 is highest volume. So V3 correspond to the lesser slope. So this one is the order of slope and order of V1, V2 and V3. Okay. Next, another important equation is there, combined gas equation. Combined gas equation. You can do it by applying Charles law and Boyle's law. Suppose a system is here A, it goes changes to B, again B undergoes changes to C. Okay, so let's say here pressure is P1, volume is V1. Okay, so N is the number of moles of gas and temperature is T. So first one, if change based on Boyle's law. Boyle's law means temperature constant. So temperature will be definitely the T and N are fixed quantities, and this will be P2, pressure changes to P2 and volume let's say V. Am I right? Next let's say change by Charles law from B to C. So N and Charles law, P are constant. So relationship between volume and temperature, let's say V changes to again V2 and temperature is your T2, let's say. Okay, so from here I can write P1 V1 that is equal to P2 V2, P2 upon V. So that implies V that is equal to P1 V1 by P2. This one is equation 1. Let's see. And here change by Charles law. So V by T that is equal to Charles law at constant pressure. So P2 here. So here definitely pressure constant means that will remain same P2. Okay. So V by T that is equal to V2 upon T2. Again here if I find out the value of V by T at constant temperature, Boyle's law. Okay. So you just find out the value of V over here again. So you see P1, V1, N and T1. So change by Boyle's law. In Boyle's law, temperature and N are constant. So N and T1 remains as such. So let's say pressure changes to V2 and V1 changes to V, let's say simply V. Okay. So next Charles law. In Charles law, the pressure is constant. So here P2 remains as such and N compulsory it's same. Now volume changes to V2 and temperature changes to T2. So you can see these are the derivations of first case, here from A to B and here from B to C. This one is V is equal to B2 into D. You just compare equation 1 and 2. Comparing equation 1 and equation 2. So what we will get? P1 V1 by P2, that is equal to V2 into T1 by T2. So that implies P1 V1 by T1, that is equal to P2 V2 by T2. This equation is called combined gas equation. Combined gas equation. Okay. And next important, I have taken several times, that is ideal gas equation. Very important. Ideal gas equation you can find out from Boyle's law. From Boyle's law, okay, according to Boyle's law, P is inversely proportional to V. Okay, so here T and N are constants. Then according to Charles' law, V is directional to T, that is N and P both are constant. Next, according to Avogadro's law, volume of a given mass of a gas is known as direct proportional to number of molecules. We have gone through it in basic concept. Here T and P are constant. So from these three equations you can tell me P is inversely proportional to 1 by V. I can write over here indirectly V is inversely proportional to P. Okay, so from these three equations V is directional to P into T by N. That implies V is equal to some constant, let's say R P T by N. That implies P here V is equal to P T upon N. Okay, let me do it first. So here V is, here something wrong is there. V is directional to N into T upon P. Okay, so V is equal to some constant, let's say R N T upon P. So that implies P V is equal to, you can write nRT. So this R is called universal gas constant. Okay, this is called ideal gas equation. Very important, ideal gas equation. Okay, so in next class we will find out the various value of universal gas constant. Okay, with some questions based on this gas laws. Okay, next we will proceed. Thank you.